when our domain is between 0 and 360 degrees, it turns out that there's going to be two angles that satisfy these inverse trig equations. And so let's go ahead and take a look at how to find both of those angles. One will be found on the calculator, the other one we'll have to do a little bit of work to find. So my first step is going to be, well, just normal. Let's find the inverse sine of 1/2 to find out what theta is going to be. And so using my calculator to find the inverse sine of 1/2, I see that that comes out to be 30 degrees. Well, that may or may not be one of your answers. Really, it's best just to think of this as a reference angle. Once we know that reference angle, our next question is going to be, what quadrants is sine positive in? And the reason I want to know what quadrants it's positive in is because my ratio is positive, okay? And so to answer that question, it's going to come back to this chart right here, the ASTC chart. And so the two quadrants that sine is going to be positive in is going to be in quadrant 1, where all things are positive, and also quadrant 2, where sine is positive. And so what I'm going to go ahead and do then is draw that 30-degree reference angle in those two quadrants. So there'll be a 30-degree reference angle in quadrant 1, and there'll be a 30-degree reference angle in quadrant 2. And then finally, to get your two answers, you need to measure those angles you just found. Remember, we measure from the positive x-axis counterclockwise. And so measuring this angle right here, well, it turns out that in fact, that's just 30 degrees. So one of the answers is what I got on the calculator. It was 30 degrees. The second angle, though, I do not find in the calculator. That angle is going to be this over here. So measuring from the positive x-axis all the way around to here, I find out that I haven't quite gone 180 degrees. I've gone a little bit less than that. And so doing some simple geometry and subtracting from 180, I find the second answer to be 150 degrees. And so there are the two quadrants where the sine of those those are the two angles whose sine is going to be positive 1/2. You can always check these very simply. Type in your calculator sine of 30, make sure you're in degree mode. You'll see that that does in fact come up positive 1/2. Okay. However, also type in sine of 150 degrees, and you'll see that that also comes out to be positive 1/2. So there's my two answers. And let's go ahead and try one more question. This time, I'm dealing with tangent, and I want to look for both angles that will solve this equation. So I'll begin the same way by using a calculator to find the inverse tangent of negative square root of 3 over 3. Actually, I take that back. Don't worry about the negative. Just ignore the negative for right now. Just find the inverse tangent of square root of 3 over 3. And I see that that again comes out to be 30 degrees. Ignore the negative sign. Now, again, that may or may not be an answer. Last time it was an answer. This time it's not going to be an answer. Really, it's best just to think of this as a reference angle. Okay. So what I'm going to do then is my next question is going to be, well, what quadrant is tangent negative in this time? Here's where the negative comes into play. And so the reason I want to figure out what quadrant I'm negative in is because my ratio has a negative value. So let's go ahead and figure out the two quadrants where tangent is negative. And again, this goes back to the ASTC chart. So the two tangents, or the two quadrants where tangent is going to be negative, well, it's not going to be in quadrant 1 because that's where all things are positive. It's not going to be in the T quadrant because that's where tangent's positive. And so the two quadrants where it's negative must be the second and fourth quadrants. So I'll go ahead and draw in my reference angle. And again, that reference angle is 30 degrees. It just happened to be the same as the last example by a coincidence. I'll go ahead and draw a 30-degree reference angle in quadrant 4. Remember, your reference angle is always with the x-axis. And then to finish the question, I'll need to remeasure my angles. You measure from the positive x-axis counterclockwise. And so again, like the last example, doing some simple geometry here, I find out I haven't quite gone halfway, I haven't gone 180 degrees. So 180 minus 30 gets me a first answer of 150 degrees, which is not what my calculator told me the answer was. We'll check this in a moment. And then finally, my second angle is going to be this circle, or almost circle, right around there. Since I've almost done a complete circle, I've almost gone 360 degrees, but I haven't quite got that far. I'll subtract off the 30 I didn't get to, and I get a second answer of 330 degrees. Okay, and so that should be those are the two angles where those are the two angles where the tangent comes out to be a negative square root of 3 over 3 ratio. But you can always check this using your calculators. Type in tangent of 150 degrees. And you're going to come up with a negative. You'll see that you do get a negative answer. However, that's some weird decimal. I don't know what the decimal is off the top of my head. However, if you type in this, if you type in negative square root of 3 divided by 3, you'll see that it does in fact turn out to be the same decimal. Also, you can try that with 330. Do the tangent of 330 degrees. And you'll see that that also comes out to be a negative point, whatever that decimal is. The key thing here is making sure that those do in fact come out to be negative, because I'm looking for negative ratios this time. But 150 and 330 are my two answers.